Hello dear students of plus one medical, non-medical, respected teachers, dear friends. In this video I am going to discuss introduction of thermodynamics, that is concept of heat and temperature, zeroth law of thermodynamics and first law of thermodynamics. Let us start. So first of all, what do you mean by thermodynamics? Thermo means heat, dynamics means flow. So it is that branch of physics in which we study the transfer of heat, that is flow of heat. And what is heat? Heat is a kind of energy that produces sensation of warmth or coldness in us. It is observed by sense of touch. When we touch a body, we say that it is hot, it is cold. So it's that kind of energy which produces sensation of warmth or coldness in us. Heat goes on flowing from a body, from a hot body to a cold body. In other words, from a body at higher temperature to a body at low temperature, till their temperatures are same. Then we say that thermal equilibrium is reached. So when temperature of two bodies become same, then they are said to be in thermal equilibrium. Heat is measured in joule in SI system and calorie in CGS system. Now, what is temperature? Temperature is a degree of hotness or coldness. Degree of hotness or coldness. Units of temperature. Temperature has 4 different scales to measure temperature of any body, and the relation of between these scales is given by C upon 100 is equal to F minus 32 upon 180 is equal to K minus 273 upon 100 is equal to R upon 80. Where C stands for degree Celsius, degree centigrade, F stands for degree Fahrenheit, K stands for Kelvin, R stands for degree Reaumur. So there are 4 different scales and we can convert temperature from one scale to another scale by using this relation. And normal human body temperature is measured to be 98.4 degree Fahrenheit. So this is a normal human body temperature, 98.4 degree Fahrenheit. Now, then zeroth law of thermodynamics. What is zeroth law of thermodynamics? Suppose we have 3 systems A, B and C as shown in figure. Let A and B are both separated from each other by a perfectly non-conducting wall, and A and B both are separated from system C by a perfectly conducting wall. Perfectly conducting wall means heat can flow from A to C or B to C and vice versa, from C to A or B. So heat can flow from one system to another system if they are connected with perfectly conducting wall. Perfectly non-conducting wall means heat cannot flow from one system to another system, that is from A to B or B to A, due to non-conducting wall between the two. Now suppose initially these 3 systems are at different temperatures. Let theta 1 degree Celsius, theta 2 degree Celsius and theta 3 degree Celsius. So leave them as such. After some time, what will happen? Temperature of 3 becomes same. You can see from these thermometers. When they come to the same temperature, they are said to be in thermal equilibrium. Now, when thermal equilibrium is reached, if we replace this perfectly non-conducting wall by a perfectly conducting wall, then no change in temperature of A or B is observed. This states that if A and B, if any two systems A and B are in thermal equilibrium with the third system C, then they themselves are also in thermal equilibrium. This is nothing but zeroth law of thermodynamics. So what zeroth law of thermodynamics states that in thermal equilibrium, when any two systems A and B are in thermal equilibrium with the third system C, then they themselves are also in thermal equilibrium. So this means this zeroth law of thermodynamics gives the concept of temperature. So this is the meaning of zeroth law of thermodynamics. When temperature difference becomes zero, so it's called zeroth law of thermodynamics, and it gives the concept of temperature. Now then there is first law of thermodynamics. What first law of thermodynamics states that when work is done, heat is produced, and the amount of heat produced is directly proportional to amount of work done. That is, W is proportional to H, or W is equal to JH, where J is called Joule's mechanical equivalent of heat, and its value is 4.2 joule per calorie. So this is basic first law of thermodynamics. Now, if dq is equal to amount of heat given or taken away from the system, dU is equal to increase or decrease in internal energy of system, dW is equal to work done by the system or upon the system. In other words, if dq is the amount change in heat energy, dU change in internal energy of system, dW is the work done by the system or upon the system. Then by law of conservation of energy, dq will be equal to du plus dw. That is, energy supplied is equal to the sum of change in internal energy of system and amount of work done. So dq is equal to du plus dw, or dw can be written as pdv, because pressure is force upon area, volume area into distance. So distance area cancels, force into distance becomes work done. So it means dw can also be written as P into dV when there is change in volume takes place. So dq is equal to du plus dw, or dq is equal to du plus pdv. So this is known as differential form of first law of thermodynamics. So this is brief description of first law of thermodynamics. Its application will be discussed later on. Now it means the first law of thermodynamics gives the concept of internal energy. That when energy is supplied, there is change in internal energy of system, concept of internal energy. So it is based upon conservation of energy. So this is first law. So then what is the difference between heat and temperature? We have studied heat and temperature, so we can differentiate between heat and temperature. So number one, heat is a kind of energy that is observed by sense of touch, or which produces sensation of warmth or coldness, whereas temperature degree of hotness or coldness. Total heat depends upon total kinetic energy of all the molecules of the system, whereas temperature depends only upon kinetic energy per molecule. So that will be proved later on. Heat is measured in joule, SI system, calorie, CJ system, and temperature is measured in degree Celsius, degree Fahrenheit, Kelvin, or degree Newton. So heat and temperature we can differentiate. We have used pressure, volume, and temperature. They are known as thermodynamical variables. We'll name them as thermodynamical variables. There will be PV diagram in different processes, or indicator diagram. So any graph between pressure and volume, taking volume along x-axis, pressure along y-axis, is known as a PV diagram. So this is the basic introduction of heat and temperature, basic laws of thermodynamics, zeroth law of thermodynamics, and first law of thermodynamics, and how we differentiate between temperature and heat. So in next video I will discuss the thermodynamical processes. Till then, stay tuned, be happy, all the best, good luck.